The next speaker is going to talk about land surface temperature and land cover for urban heat island analysis. This topic is of particular interest to environmentalists, urban planners and designers since the speaker discusses about various factors for the cause of increase in outdoor temperature and thereby affecting the human comfort level in the outdoor spaces. Our speaker is from Department of Architecture, Planning and Interior Design, Amity University, Dubai. It gives me immense pleasure in welcoming Dr. Niva Rana Mahanta.
Hello everyone, this is Dr. Niva Rana Mahanta. I'm working presently at Amity University, Dubai, and with me today we have Mr. Abraham Samuel. We both will be talking about urban heat island and land surface temperature for built environment in urban areas. Now, we all understand that this particular conference was actually organized against a lot of adverse situation going on all over the world. On behalf of Amity University, I sincerely thank the organizer of Icon Best 2021 and giving us the opportunity to speak to everyone. And this is also a learning experience for us. Cities have been growing and the need is ever changing. The trend is emerging and it is very, very rapid that all the cities are developing. It is inevitable. So, while developing the city, we all are trying to make the city sustainable and resilient. Now, what is urban heat island and land surface temperature to do with any kind of built environment that we are trying to develop in the cities? Today, we are going to talk about the importance of urban heat island and land surface temperature, including with land cover, that is mostly, as we know, as land use land cover plans for master plans. We are going to discuss this in detail. We are going to talk about neighborhood which has developed during last 10 years in Dubai. This development is known as Dubai Silicon Oasis. It is a very smart neighborhood, we must say, and developed as a sustainable neighborhood as well. Now, build structures in urban area and impervious surface areas, meaning the man-made surface areas, help in creating such urban heat island. For this lecture, I thank you once again all the organizers for giving us the opportunity. And please now allow me to share my screen. The topic we are going to talk about is that land surface temperature and land cover for urban heat island analysis. Here we had to do this topic because this is a very, very important factor which is actually hampering the energy conservation in the city areas. To start with, we have actually going to talk about and discuss about urban heat island and land surface temperature and land cover. Then we will tell you that what was the objective of this kind of studies and why is it necessary. Then we will also discuss with you the methodology, how we have gone ahead with this case study of this particular neighborhood in Dubai. And then we are going to talk about the case study and a model project development of Dubai Silicon Oasis. In short, we call it as DSO. And then we will also discuss about the mitigation strategies. For that, we must actually first know what is an urban heat island. These are the small heat trapped in urban built spaces, within the built spaces, I must say, and that creates a heat island. And how does it develop? It is a temperature difference which is between the urban area and the rural area, which we have also been calculating with the formula delta T U minus R, that is equal to temperature urban minus temperature rural. Here is the difference of temperature in urban and rural area because of this urban heat island. the temperature is always more during night. The temperature difference is always more during night, I repeat, in both winter and summer. There are many factors which are responsible for this temperature increase. Okay, they affect directly or indirectly in human comfort level in the outdoor spaces, and again it reflects in the indoor spaces as well. Built structures in urban area with impervious surfaces create lot of association with urban heat island, and they are the main factor. The built forms are the main factor for creating urban heat island. Now, if we have to know what is the lands, what causes the urban heat island, as I just mentioned, that the built form, the city form is one of the factor affecting the urban heat island, and these city forms are mainly they are mainly associated with population, the number of people living in that space, the other built structures in the open and indoor areas, and this function is actually mitigated by more of use of water and energy. Now, when we talk about urban heat island, we have to start from the micro level to the macro level. The micro level being the space where humans are living, and then it comes to the outdoor and then to the regional city level. When we talk about the land surface temperature, it is the temperature which is measured on the surface of the earth. Now, you can very well understand that if the surface of the earth is made up of natural element, then definitely that surface temperature is less. Now, we human being are making all the man-made structures specifically. If it is with impervious structures, then it's going to be very hot. It will get more heat. So the temperature is measured. Now, how this can be done? Of course, when you are on the site and you measure the temperature on the site by a thermometer or a temperature measuring the tool, then it is okay. It is better. It is more accurate, I must say. But then it is not possible. It takes lots of time if you have to go place and place, and then if you have to measure for distant places. So there is a new method that is applied to measure this temperature, that is known as thermal remote sensing. With this kind of thermal remote sensing, we can take the temperature of any place in the world, anywhere, and not only the temperature, it can be any kind of physical form of that place also. We can measure the temperature. It saves us lot of time, and we can do it sitting at home anywhere in the world, and we can do a lot of amount of work at the same time. For this, I would like to tell you that what was the study objective and what is the methodology we adopted. The study objective of that neighborhood area was to evaluate the data of land cover and land surface temperature responsible for causing urban heat island effect. Now, when we talk about the land cover and the land surface, all of us know that when we make the master plans of an area, we make a land use land cover LULC plan. Why we make that LULC plan? Because we need that at least 30% of the area of a city or an urban precinct should be covered with green blue infrastructure. What we understand by green blue infrastructure is that the natural vegetation and blue means the water. So nowadays it is given a lot of importance to green blue infrastructure on a city fabric. Next objective was mapping of these urban mass in correlation to open spaces based on the patterns of urban development and land surface temperature to give an understanding of the microclimate and its effect on the important. How hot it was when a particular built environment was made, how cooler it is or how hotter it is. But if we use a mitigation strategy like, it is like if we have intervention of blue-green infrastructure, then what was the result? So what is the success story? We had the objective to study this. Then again, we had the objective to identify factors that can improve the human comfort conditions in the urban spaces. For these objective, we have set up some methodologies to study. Now, study on the land use, land cover data and temperature data were collected through the analysis of satellites images. And these images we have taken from repository of Dubai government entities like Dubai Airport Authority and Mohammed bin Rashid Space Center. a satellite imagery service provider in the UAE. We had also taken some images from the repository of MET University satellite hub. We have a satellite station here, ground station here at MET University. So we had the opportunity to collect some images from them and use it. Again, all this data captured, it has to be analyzed for LST and land cover area on built environment were used to calculate and analyze the urban heat island effect, and the progression was over from 2004 to 2019. We had taken this complete span of time. The heat effect study during the critical high and low months of July and January. This is with respect to the contextual and climatic condition of the local area of Dubai. A study on physical characteristics of the land surface and its treatments for the surfaces like asphalt roads, concrete pathways, rooftops, desert land, and open grounds, ground cover feature has been analyzed. We have taken both impervious and green covers. Again, at the end, we had actually discussed about mitigation methods and strategies developed to improve in the living condition of the urban areas with growing densities. I would like to hand over this presentation now to my colleague, Mr. Abraham Samuel. He will be talking about from the, I think he would start with the urban heat island, the causes of urban heat island. Thank you so much.
Thanks
Mr.
a lot,
Abraham,
ma'am.
can you join, please? Yeah.
Thank you, everyone. And it's a brilliant opportunity for us to share our knowledge. As we had been hearing about urban heat island effect, the trapped heat, and which is actually one of the outcomes of the development in a city. In the case of Dubai, we could actually say this is more diverse, and it's with the kind of development with the time it has actually come up with. One of the challenge with an extreme climate, the conditions which have a very hot and dry climate. Second, the area, the land surface with the character and the nature of being the desert, which is spread across, letting it have high temperature. And then also, when you look at the climatic conditions across the year, is actually one of the very, very strong aspect to understand. When we look at this aspect, it actually varies by the micro conditions, by the conditions of the region. So, what we actually do in our study is to look at it at a mac and look at it at the level where the whole city is seen at one level with the way it has been growing with the time, and then look at the factors which has been there in the city with reference to the development, the densities, the kind of pattern, the kind of ground covers, water bodies, and how this has been further adding on to the urban heat island effect. And then when we actually take it up with the datas, with the analysis, where we actually see how we have tried to understand the land surface temperature aspect based upon the consideration of the slopes, the contours, the maps, and how this with the various varied monitoring tools and devices has helped us to look at it at a more precise level. So straight at this point, we'll actually get on to understand the region. Looking at the climatic zone, looking at the desert region, we actually took up to understand how the temperature, how the land surface temperature has been one of the varying factor and a very important factor, which actually has led to the increment of the urban heat island effect. And then as we look through the studies, we would say there has been certain differences to the land surface temperature due to development, which is actually a positive sign to say when the desert has developed, the land surface temperature has got changing and it has actually reduced. But again, with the development, there are other factors which been a cause to the urban heat island effect due to the conditions of the climate, letting a conditioned environment being required with the buildings to make more heat being generated, which is being actually emitted on the exteriors. And that is one factor where the temperature within the urban context has a varied temperature in consideration to the climatic temperature that exists. So on the study, one could easily understand the level of working of all the mechanical devices, the traffic, the vehicles, and the kind of activities of the city has then added to the trapped heat aggravate more and cause a more dangerous scenario of living. So looking at the whole study, we start going to study with reference to first we go to the Dubai as a whole, and then we look at closer area of one neighborhood so that we could actually help and understand in a very closer perspective with reference to the factor of time, with reference to the scale of development, with reference to the variance of the change, which is to the ground conditions, the built, the ratio of built to open, the densities, the whole factor of the city with a certain infrastructure which has been added as green and the blue corridors. And then what are the effects of that onto the factor of urban heat island effect or the land surface temperature. So before we get into that, let's look at a larger picture. And when we take a glance into Dubai, it's very interesting to know a city, a desert which actually at one point across the coast, which had a certain development, and the economy has been a part to have the development take up a certain shape. And you could see that that whole pattern has actually changed over the period of time, where the pictures captured here shows aerial pictures from the 1960s to the 2015, where one can understand how the population has been growing over the period and trying to understand that the growth rate with a certain percentage over a land area. And when we look at this development and trying to understand how this development is in certain way a part which takes to see the effect into the urban heat island cause. So let's go and understand further what happens when we actually look at the Dubai in its development. So let's go to the next slide. Dubai, as in terms of the area, it's marked as with the red. Dubai is a city of pattern. Dubai, a linear city with certain roads working parallel. Again, Dubai, very famous as an aerial city, where you could actually see the city has got certain interesting patterns which are man-made, which are islands. Now, when we look at this city, understanding the city with the perception of how it has grown, how it has certain architectural marvels, how the city has tried to create an urban context, which is very interesting with this whole development. So, if we look at the slide further, which is the next slide, we can understand how the classification of the mapping can be now further understood with reference to knowing the city, with reference to what kind of density the city has, the population, the areas where you could see the ratio between the built and the open, the surfaces being impervious, the surfaces having green patches, the surfaces having a certain wind pattern and its flow which is maintained. So when we look at the image onto the left, the image helps us with the legend to understand the kind of patches that are becoming the lungs to the city. And now trying to compare this image with the image on the right, which is actually helping us to understand the example of the daytime land surface temperature at a particular time of a particular year, a particular month on a day, and captured through the Landsat. And when we look at this, we could actually see the area where the green patches and the densities are low can easily be understood through with the variance of the heat island effect. And that very clearly indicates a certain part where the range is quite higher and a certain part where the range is quite green, which actually tries to look at this into a more focus to understand what could be the reason. And one of the very interesting aspect is the kind of the densities, the open spaces, and what the ground covers are. So that made us more curious to look at this to a more detailed level and moving on from a macro of the city of Dubai. And before we step into the micro level, trying to take a glance as to what was the change over the period of the years where we collected to understand the information between 1999 to 2009, and the analysis helping us to understand the effects the planners, the designers, and their measures of development has been a part into management or the development of the urban precincts has been creating some kind of level of mitigation to the urban heat island effect. So at one level, we can say the deserts, the desert city having a high land surface temperature because of its conditions of the sand and the reflectance. And when we see with the development, we could say that there is a change to that desert condition when we look at the the variance between the desert areas to the urban areas. And now, when we look at the urban areas which has been developed from the time of 1999 2009, you can actually see some positivity, and the positivities are due to certain mitigation measures which has been taken up. But still, you can actually say there are certain points where it's high, where again we have got opportunities to make mitigation measures be applied at a micro level scale, at a scale of individual plot, at a scale of individual building. So let's look at further in how the whole map can be understood with the help of a land use to get more clarity as to what kind of development is happening across the city, the spread of the development with varied kind of activities and surfaces, which helped us to little get a clarity and classification and get more understanding as to what could be the root causes for some areas with the variance. So when we look at the next aspect we wanted to study was this factor of urban heat island and land surface temperature as one very important parameter, the temperature. What we identified was to take a path to mark years, certain months. There are certain months which are quite desirable. There are certain months which are undesirable and quite difficult and extreme to live, where the temperatures go high. The months in the hot seasons are more than the desirable months, the winters. But one of the interesting study which we could gather at this point is there were certain months and certain years where the graph actually shows a variance in the temperature, where the variance has been seen as a cause of development in the desert, and the development has actually changed the nature of the desert, and that has been one of the factors to say that the land surface temperature has got varying from the point which was a desert to urban areas which are actually developing. So when we look at it further and look at the maps and look at the understand the maps with reference to the temperature variances, we actually wanted to study more and get a clear picture as to how this reflects with the study area, which is a more focused study area, the Dubai Silicon Oasis, a neighborhood which has been marked as one of the green development, one of the sustainable development, one of the mixed use development, which actually has got all special economic categories, housing of different typologies, housings of varied scales, industries, commercial building, institutions, and this whole neighborhood actually has been developed over a period of span which we looked up here with 2004 with the image on the top, and slowly you can see how the whole development started with a change happening towards the 14 where the development is partially complete. But again, to look at this development with a future approach of what the city was having as a forecast and trying to understand the Dubai Silicon Oasis, which read as DSO, the master plan, where there is a clear understanding of how the developers, how the designers, how the stakeholders have actually taken up a consideration of the urban masses, consideration of the densities, consideration of the climate, the shading areas, the way it has actually created the wind corridors. It has actually considered giving open spaces, public spaces where actually the ground covers make the green corridors both active as well as in passive use. And then the landscape with the water bodies have really contributed to mitigate to the urban developed masses as well as the urban heat island effect. So when we look at the scale of development, we can actually say comparing from the desert, the land surface temperature, to considering to the development which has happened across the city, as seen in the picture, large water bodies which has been created, which are man-made ponds or lakes, where you could actually see the water becomes one, where the evaporative cooling factor keeps a certain temperature control, certain aspect of greening the city with not just making it uh, just passive, but it's very active with people actually using them as central corridors, playgrounds, urban spaces for people to come. One of the interesting aspects for us during our study was a reading where we could actually to understand application of blue roads in certain part of Middle Eastern cities. One, the Qatar, Doha, trying to test has given a positive result, and we actually could take this as one of the very interesting ways to battle and combat the urban heat island effect. This, when we actually look at it at small drop levels, we can actually say from the city where every city has a good percentage of transport corridors, then looking at further the aspect of the micro level, getting onto from the city, from the neighborhood to an individual plot, where I believe each plot with its development has a very strong responsibility of each of its stakeholders to convert the surface areas with materials where the reflectance factor can be reduced. So when we look at that, we actually came across getting to the conclusion that the possibilities of mitigating urban heat island as well as trying to work with the land use, land cover, and trying to work with the adversities that it could develop on a longer day could be dealt with improvement, with mechanisms, means which can be positively possible. And it has shown through the studies that even with the partial development of the precinct, the neighborhood, there has been a remarkable change where with the mitigation of having the blue and green corridor as one, the possibility could be much better if the road surfaces are again treated as blue road, and then probably looking at the individual plots, each building to then mitigate it further with the roof, the grounds, and the vertical surfaces also becoming a contribution to have surfaces greened, which is not just contributing to the urban heat island but also improving the ecosystem, having a balance. Next is it's also improving the air quality, reducing the dust aspect, and giving a healthy living environment to the habitants in the city. So with this, we would like to take a message across to all the participants, all the designers, all the fellow citizens who have a strong responsibility, and we can only give back to the cities we develop in the future by not just getting concrete jungles, but create livable cities by considering what heat island effect we cause could actually be reversed as with the steps counter the land surface temperature and make it more possible to have a healthy livable environment. Thank you.
Thank you everyone for listening and giving your time. Thank you so much.
Thank you, Dr. Niva Mahanta, for your enlightening presentation on land surface temperature and land cover for urban heat island analysis. Thank you. Now we shall take a short break for a sponsor video, post which we shall proceed to our next speaker.
Epoxy adhesives are widely used in the industry because of their high strength, chemical resistance, and the ability to adhere to different surfaces. But almost all of them have low impact strength and low UV resistance, which makes them weak after long-term use, under stress and limitations. To combat all these issues, we are introducing Bond-Tight Pro. Bond-Tight Pro is a high-performance two-component multi-use new generation epoxy adhesive system with room temperature curing. It has very high impact strength, excellent shear strength, better UV resistance, better coverage, and so much more. And it is to be used for bonding various similar and dissimilar materials such as metals, ceramics, wood, leather, rubber, marble, glass, and a lot of other materials. Bond-Tight Pro is very easy to use. The directions to use are really simple. Step 1. Clean the surface and make sure it is free of dust, unsound material, loose plaster, oil, paint, grease, algae, and corrosion deposits. Step 2. Take equal quantity of part A and part B. Step 3. Mix it for 1 minute with the help of bond-tight applicator to attain uniform color. Step 4. Apply on the surface. Step 5. Clamp or support the surface for 4 hours. It will attain full strength in 24 hours. And that's all there is to it. You can use it for speakers, marble pasting, automobile repair, and hardwood handicraft. Bond Tight Pro.